Alright, this lovely video we are going to talk about the basics of right triangle trigonometry. Well, we'll start with this lovely little picture here, obviously of a right triangle. I'm going to introduce a new symbol, two of them really. These are just Greek symbols that are going to be arbitrary for angles. So this symbol that looks like a little yin-yang or a Pepsi symbol or a circle with a little squiggle in the middle of it or something like that. It's theta, and it's often used to represent some unknown angle. And this guy, the B with the tail on it, that's beta. And capital beta. Same difference. It is basically just arbitrary variable for angle. That's not the important part, but I did want to put those guys in there. The important part, and maybe I'll get a couple of different colored pens going on here so I can color code some stuff. Blue, sweet. All right. Okay. So, one of the first things that we are going to need to do when setting up the problem, and I'll write out a procedure in a second, but it's very important relative to whichever acute angle we're using that we define our side lengths. So we'll start with the hypotenuse, which obviously will always be opposite the right angle, and we will abbreviate, and we will call the abbreviation for the hypotenuse just HYP. Now the other two sides are going to be opposite and adjacent, but relative to whichever acute angle we're going to use. So that's why I want to get some different colored pens going on here. Of course, I already used blue, so that was silly. Anyways, I'll use theta in black, and should have wrote beta here in the first case, but I'll do beta in red. So here, if I'm orienting myself at angle theta, this side right here is going to be the side that's adjacent to theta. And we will abbreviate adjacent ADJ. And this side over here, that's the side that's going to be opposite theta. And we will abbreviate opposite OPP, just for abbreviation's sake. But if I, red pen time, orient myself here at angle beta, the hypotenuse is still the hypotenuse. It's always the hypotenuse.
Excuse the interruption. Anybody leaving the building, please be advised, as you exit the building, you will not be able to take a left. You will only be able to take a right out of the building. There's been a little incident with a tractor trailer. They're working on it, but nobody can exit left. You can only exit right. Please let me know if you think this is going to present a problem for you. Thank you.
Did you kids get all that? Okay. Sorry, where was I? Okay, so if I'm here at this angle, the hypotenuse is still the hypotenuse, opposite the right angle, and that will always happen. But if I'm orienting myself at this angle, now this side, which was opposite theta, this is going to be the side that is adjacent to beta. And this side, which was adjacent to angle theta, if I'm orienting myself at this angle, this will be the side that is opposite beta. So, adjacent, opposite, hypotenuse. We need to, when presented a problem, just sort of orient ourselves on the triangle so that we're very sure you know, certain sides are opposite acute angles, certain sides are adjacent to acute angles, and then obviously the side that's opposite the right angle is the hypotenuse. So that's just a little bit of orientation. Now let us get the actual definitions for a few. We're only really going to look at 3 of the trigonometry values right now. There will be 3 more that you will probably discuss in like a pre-calculus course.
Sorry, one more quick interruption.
This is embarrassing.
Right on Spring Street. Not a left. Pardon me, brand new information.
Oh, geez.
For Millis PD, we now have to go out through the gate near the tennis court. So nobody's exiting Spring Street at all. If you need to leave, please exit through the tennis court. Thank you.
Okay, now that we know how to leave, let us take a look at the definitions for the 3 basic trig functions. Once again, there's really 6, but you'll learn about the other 3 later. All right, so I'm going to create a little table here. I'm a big fan of tables. My first column will be the name of the trigonometry function. The next column will be abbreviate, and I'll abbreviate abbreviation, and then the definition in our third column here. So the first trigonometry function we are going to use is the sine function. You'll probably see it on your calculator, abbreviated SIN. I know it looks like it says sin, but please pronounce it sine. You kind of sound silly if you say sin. Anyhow, the definition for a right triangle, anyways, is that the sine of acute angle theta is equal to the ratio of the opposite side divided by the hypotenuse side. The next trig function, trigonometry function, we'll take a look at is going to be the cosine function, abbreviated COS. Same deal, just say cosine, don't say cos. It kind of sounds silly. And the definition of the cosine of acute angle theta is going to be equal to the ratio of the adjacent side divided by the hypotenuse side. And the third trigonometry function that we are going to use is the tangent, abbreviated TAN on your calculator, and the tangent function for right triangles anyhow will be defined. The tangent of acute angle theta is going to be equal to the opposite side divided by the adjacent side. Now, I am always going to provide these formulas on any test or quiz, but there's a neat little acronym that is sometimes used to help remember these 3 definitions. If you take a look at the first letter of the trigonometry function and then the first letters of the side lengths, that the definition of the acute angle is equal to the ratio of these sides. Sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, tangent is equal to opposite over adjacent. Some clever guy figured out that if we took a look at all those letters, it spells out the very Native American sounding SOHCAHTOA. Just like PEMDAS, this is not actually a math definition, it's just an acronym to help you remember these definitions. And I want to keep my videos under 10 minutes, so that's the basic definitions. We will take a look at some example problems and how to use these lovely things in conjunction with our calculator to solve for missing angles and side lengths of right triangles.